Hi, my name is George Diamond, and today we're going to be talking about the mean value theorem for derivatives. Now I'm going to put my basketball down here and we'll get started. Now in our textbook, the mean value theorem is in section 3.2. Now this is video number 1. And now in video number 1, we're just going to be talking about the mean value theorem. We're not going to be doing any examples or anything like that. That we're going to do in video number 2. So if you want to see some examples, go ahead and take a look at my second video on the mean value theorem. But today we're simply going to talk about the mean value theorem. I got some information on my PowerPoint here, and I'm just going to pull the PowerPoint up and we're going to talk about the mean value theorem a little bit. So first of all, let's get right to it. Now the mean value theorem is simply says, right, that if f of x, or a function, is a differentiable function over a closed interval from a to b, okay, then at some point between a and b, f of b minus f of a over b minus a. Now, some of you may recognize this as the average derivative. So the average derivative is going to equal the derivative at some c value. Right, so when you look at the mean value theorem, now what this implies simply is that f of b minus f of a over b minus a. Now this would simply be the slope of a chord from a to b. Right, so this would be the slope of a chord. Right, so the slope of a chord, and that would equal the instantaneous rate of change. So the average rate of change. So the average rate, okay, of change. So that would be f of b minus f of a over b minus a. That would be the average rate of change. That would be the slope of a chord from a to b. Now that will equal, okay, the instantaneous rate of change. So instantaneous rate of change. So of change. Now to get the instantaneous rate of change, remember we use the derivative. So the average rate of change from a to b is going to equal the instantaneous rate of change at some c value. All right, so at some c value. Now let me see if I can illustrate this a little bit with a little graph. I've got a graph on my next slide. Let's pull it up. Okay, but first, a couple of things I want to point out. In the mean value theorem, it says that the function has to be differentiable. That means it has to be continuous. So differentiable implies that the function is also continuous. So no gaps, no jumps, nothing like that. So it has to be continuous. And it has to be differentiable. Now, to be differentiable, there can't be any sharp corners on the curve. It has to be a smooth curve. So a smooth curve, no jumps or gaps. So if it's differentiable, that implies that the function is also continuous. Right, and also the mean value theorem only applies over a closed interval. Right? So we're talking about just a part or a section of the curve, so a part of the curve, right, from point A to point B. So once again, it only applies over a closed interval. Okay, also now basically what the mean value theorem says, like I said a second ago, the mean value theorem says that at some point on the closed interval, so at some point, the actual slope, what would be the instantaneous rate of change, it equals the average slope, so the average rate of change. So the instantaneous rate of change will equal the average rate of change. So this is what this implies. It simply indicates the actual slope equals the average slope at some particular value. As long as your curve is smooth and there's no jumps or gaps and it is differentiable. So let's take a look at a curve here real quick. So here's so you can see my curve here. I've got one on the PowerPoint that we drew. So this is f of x. So this is my curve. Now let's pick out a section of the curve. Let's say the section of the curve from A to B. So we're going to put, point A right here, and point B right here. So we're talking about just that part of the curve from A to B. Right, the rest of the curve we're going to ignore. Right? So just that part of the curve. Now you can see the chord, right, connecting A and B. Now that would simply be the average rate of change. Now to get the average rate of change, we use that word, the slope of the chord would be f of b minus f of a over divided by b minus a. Right, so that would be our average derivative. Okay, that's our average rate of change. Okay, that would simply be the slope of our chord. Now, according to the mean value theorem, as long as your curve is smooth, right, and it is differentiable, okay, between A and B, there has to be some x value. Now we're going to call that x value c. So there has to be some x value where if we were to draw the slope of a tangent line on this curve, the slope of that tangent line would be parallel to, that is equal to the slope of this chord here. So let me see if I can sketch it on here. I did it on the PowerPoint. There it is. So if you look at the slope of this tangent line, it would be parallel to the slope of that chord. Okay, that means that your parallel lines have equal slopes, and that means so that indicates that these two here would be equal. So the slope of your tangent line would equal the slope of this chord. Okay? Now to get the slope of your tangent line, you have to use the derivative. So the derivative here, to get the slope of the chord now, we simply use the slope formula, f of b minus f of a over b minus a. Right? So this is kind of illustrates what we're talking about with the mean value theorem. So from point A to point B, there has to be some point on the curve. Right? So that would be this point right here, where the slope of that tangent line is parallel to, that is equal to the slope of the chord from point A to point B. Now, that x value is right here, so this is point C. So at point C, the slope of your tangent line, so with x is C, the point slope of your tangent line is going to equal the slope of that chord. Now, this is what the mean value theorem says, all right? So, moving right along, now a couple of, now we're almost finished with our first video. This is pretty short. There's a couple of things I want to mention here real quick. That a function is always increasing over an interval. Okay, if the derivative is always positive. So if you got a positive derivative, that means the slope of your tangent line will be positive. So the derivative will be positive if the function is increasing. Also, a function is decreasing over an interval if the derivative is always negative. So a couple of things I want to point out. And like I said, in the first video here, it's a short video just kind of talking about the mean value theorem, did a little illustration. In the next video, we'll do some examples, and I'll show you some applications of where the mean value theorem can